Well, hello, everyone. Thank you for joining me here at J4K. It's just an awesome event, and it's great to sort of virtually see you all. But thanks for coming. My name is Mark Heckler. I'm going to be talking about RSocket and Spring and giving a full throttle introduction. And I actually had titled it that before I realized that we're very short on time here today. So it's going to be really full throttle with afterburners, but here we go. I am a cloud advocate for Java and JVM languages at Microsoft. So that's a bit of a change here in the last few weeks, several weeks. But I'm happy to be here, happy to have landed here, and it's just a great organization I'm a part of, and I'm thrilled to be here. So if you have any questions, comments, or feedback, I will hopefully have a few minutes at the end. If you are like me and you think of something 10 minutes after you disconnect, that happens. It inevitably happens, probably more to me than anyone, but don't be sad. Just reach out to me. You can reach me by email at markheckler@microsoft.com or mark@thehecklers.com, or best yet, on Twitter. I live on Twitter, so ping me on Twitter. Testing. Okay,
I hear you.
that sounds good.
That sounds good. You're back on.
Okay, well,
thank you.
This is
now you're less time.
Yeah. Oh gosh. And a backup mic, but that's good. You always have a backup. So, all right. Yeah. So here's the new book. A couple of months ago, it's been out for a couple of months. If you're interested in knowing more about Spring Boot, getting started, if you're new to the boot environment, boot tool chain, that's great. That's a great place to start. If not, if you're just looking for maybe an exploration of topics that you may not have seen before, or maybe you want to explore a little more in different ways or more deeply, then check it out. If not, that's fine too. But there's the link. You can go, and if you're not already a Safari Books online member, you can get a free trial and follow on Twitter or whatever. It's all good. All right. Whoops. Let's see. Go back to here. There we go. So we're going to be talking about Spring Boot and RSocket today, and RSocket is built on the Reactive Streams API. And a little bit about Reactive Streams. Reactive Streams came into being because imperative or blocking Java. It's kind of not necessarily a perfect match in terms of terminology, but we'll go with it. It's probably as close as we can get in a short time. But rather, blocking Java is very good for performance up to a certain point. So if you have a service one, which is, let's say, a consumer service, and service two, which is a producing service or a backing service, and you have up to, let's say, 100 requests coming in from various service ones to that backing service, everything's great if you can handle 100 requests coming in. But what happens to that 101st request? Well, it's a blocking API, so it blocks. It is blocked. It's waiting, and at that point, performance goes from being very good, really, relatively speaking, to very well, potentially very bad. The Reactive Streams API came into being because several companies, several organizations felt there should be some way to manage scaling to a greater extent than was typically possible in a blocking API. So several companies got together again to kind of brainstorm on this and produce a very low level, very granular API, which is just this: 4 interfaces. And they are indeed interfaces because folks can have different implementations of these and validate that they are indeed interoperable. So you have a publisher interface, which is the thing that produces values; the subscriber interface, which is the thing that consumes those values; a subscription, which is the contract entered into between subscriber and publisher; and then a processor, which actually incorporates the subscriber interface and the publisher interface, because it will receive values, manipulate them in some way, and then pass them on to its subscribers. So what the Reactive Streams API does is allow you to insert an event loop into your application, which is very super helpful, because again, you can handle a lot more requests coming in and service those requests much more efficiently at a greater scale. Now, at that point, a lot of times people will look at it and say, well, that sounds like asynchronous programming. And sort of, yeah, the asynchronicity is a part of it. However, asynchronous programming by itself has a couple of problems. One, it can be a little messy. Callback hell is a real thing. The other thing is that asynchronicity does not do anything for flow control. So if a very slow consumer says, well, give me everything you have, and that producer, that backing service says, well, I have 5 million values I will send you, so I will send them all to you once I get them bundled up and they're ready. That slower consumer can be overwhelmed. And asynchronicity really doesn't do anything to stop that. It just lets the consumer go ahead and do other things while it's waiting for that response. So it doesn't just block and wait. But again, it doesn't do anything to protect it when those 5 million values come downstream. With a reactive streams implementation, you have back pressure, and back pressure allows that slower consumer to say, look, I know I'm slow. I know I'm on a slow connection. Just give me 50 values at a time. Give me everything you have, but only 50, only the first 50. And then when I process those, I'll request 50 more or 500 or 2 or whatever the number is. So it allows you to exert back pressure and shift that control to where we have more control in most cases versus maybe a remote client to our, we now have control at our backing service, our cloud-based service. So it gives us a lot more tools in our tool belt to manage the control, to manage the flow, and not overwhelm downstream subscribers. So that's really a very quick nickel tour. Again, we're kind of pressed for time. RSocket is built on reactive streams, and RSocket extends the basic model of interaction, which is in an HTTP-based interaction, typically just request response, and with various different workarounds that can be employed. But RSocket builds on that. It incorporates that request response interaction model, but it also provides other interaction models like request stream, because you may not just issue a request and get a response. You may issue a request and expect many things coming back, right? And the reactive streams publisher represents that very well, because a publisher can be zeroed in values and they will come in when they come in. So it can be 1 per second, 1 per day. You could get 5 values and then wait a week for the 6th value. That's a sporadic publisher, right? But it allows you to issue a request and get that stream back. It also, another interaction model is fire and forget, because there are many cases where you need to send a value and you don't care about anything coming back. You don't need to wait, process, discard, you just move on. And then, of course, perhaps the most interesting one is the bidirectional channel. And this interaction model that RSocket supports and provides is a way that for either side to initiate conversations, because with RSocket, while you obviously, to get things started, have to have one service listening for connection requests from another, once that connection is established, they are effectively peers. The distinction between the two evaporates. So either side can initiate a conversation or a monologue in the case of fire and forget. And it's a multiplexed single channel that allows those two to stay, to communicate in various different ways. I also will point out, because I sometimes kind of launch into this and forget, but in terms of Reactive Streams Publisher and RSocket, that's built around Project Reactor, which was a Pivotal / VMware creation with a lot of different input from a lot of different players. But that particular implementation of Reactive Streams takes the idea, the concept of a publisher, and specializes it into a mono and a flux, which very closely parallel what we have in the blocking Java world. If you have a method returning a single value, that's great. If you have it returning an iterable, a collection of values, that's also fine. You can have 0 to n. And in terms of reactive streams, and in terms of Project Reactor, a mono is 0 or 1 value, which corresponds to that returning 1 value. A flux is 0 to n values, and that can be a small grouping of those values, like 8 at a time, or 10 or 15, or it can be, again, that sporadic publisher that just keeps going, maybe very sporadically over a long period of time. So let's code. So let's see, how are we doing on time? Wow, 15 minutes. What could possibly go wrong? Okay, we're going to launch in. Pardon me. Okay, so where did my...
Actually, you have about 10 minutes.
Oh my gosh, you're killing me. Okay, well, we'll maybe jump ahead a little bit. I'm going to create a couple of services here. We're using the Spring Initializer to get us started with a couple of Spring Boot-based applications. And by the way, RSocket is not dependent on Spring Boot. It's not dependent on Java. There are several different languages that are supported. And of course, we just even show here Java, Kotlin, and C++, but there are many others. But if you're using Java or Kotlin, Spring Boot is perhaps the fastest and easiest, most efficient way to get up and running quickly. So I'm going to create thing 1 and thing 2. We're going to add a few dependencies here. So reactive web, there we go. And then RSocket, of course, and Lombok, because I'm a lazy developer. So we'll just do that. So I'm going to create this, and we'll drop thing 1 on our desktop, thing 2 we'll do the same thing. And I intentionally call them this because once we've, again, established that connection, they're peers. So let's open this up. Oh, look at you. There we go. So let's open up thing one. There we go. And we'll open our POM. Yes, that's fine. That's perfectly fine. Let's go ahead and just in the interest of time, let me open that up, thing two. And we'll drop those side by side and we're off and running. Okay. So thing one will be our consuming service, our client, if you will, to start with. And thing two will be our server, for lack of a better term. So here's our code, just our main application class, main method. Now for our properties, I'm just going to specify a server port. So we can have a port that's non-default port because it defaults to 8080 for Spring Boot apps. We don't want a port conflict between the two. And then I'm going to designate an RSocket server port of 9091. And this just helps me keep things straight in my mind. So I'm going to define a domain in this case. We're going to make this an aircraft domain because I use live aircraft flight data that I pull in. It's fun, again, pilot. We'll be collecting a few different bits of information from planes overflying. So call sign, registration, flight number, and type. And we also want to track the altitude because that's kind of cool, and heading and airspeed. And also, let's see, we want to collect the actual position, right? So latitude and longitude. And I'm just going to grab that and go over here to our application properties and here, and we'll just drop that here. I just hate copy pasting, but here's where we are today. So I'm going to create a controller class, and this will be my thing to controller. And I'm going to create a message mapping. And this is how we identify our RSocket mappings that we need to connect to from other applications. And I'm going to skip a couple of those interaction models, the request response, request stream, and the fire and forget. We're just kind of skip straight to the channel because if we have extra time, I will happily go back. But I want to show you some really kind of cool things here. So aircraft, we're going to send back a flux of aircraft, which again is a publisher. Now we need to receive some data, right? Because this is a bidirectional channel. We want to get data from our thing one application. So I'm going to have some weather data here, and weather is very important for a pilot. So we want to have a timestamp for when this weather observation was taken. There we go. And also the actual observation itself. So we'll use that. And once again, I'll go over here. And there we go. So now we're going to do our channel. We'll just define this. And we're going to receive a mono of weather, right? Come on, IntelliJ. There we go. And we'll call this our weather mono, cleverly enough. Actually, you know what? We're going to make this a flux of weather because we're going to get a bunch of these. Weather flux. And we will process this. Let's see. So return weather flux dot unsubscribe, do unsubscribe. So I'm going to take that sub and we'll just indicate that we're subscribed. And then we'll do on next, and we'll take our weather value that we're getting and we'll kick that out. And of course, it's all sunny, right? That's the good kind of flying weather. And then we will take, when we receive a value, we'll switch that and we'll map that to a flux going back out. Now, in order to get our aircraft data, I actually need to connect to an external API that I have to provide that data feed. So I'm just going to create a reactive web client, and we'll do that by creating, and I'm going to point that to http://localhost 7634 aircraft. And that's just a service that I have running in the background that I can pull for current aircraft. So I'm going to take my weather value, each one that comes in, and I'm going to in turn call that client and retrieve those values, convert the body of values to a flux of type aircraft, and send it back. So I'm going to go ahead and, well, actually, before I do that, I'm going to do a little cleanup here because when I disconnect, I don't want it to be ugly and a little unceremonious. So I'm just going to set up a hook here. So when it drops a connection, we'll just do this. Connection terminated. This is not a have to, but I just think it's much cleaner that way. So let's go ahead and start that. And again, just by setting this property at our RSocket server port, this is enough for Spring Boot's auto configuration to say, look, you want this to be an RSocket server? I can figure that out. So very simple. And again, to keep this very simple for the time that we have, so I'm going to create a thing1 component here. And let's see, well, first I need to create a bean that allows me to provide an RSocket requester. The fact that we have RSocket on our class path means that Spring Boot will inject a builder so we can use that to create our client connection. So return builder dot, and we'll use TCP for underlying transport. You do have options, WebSocket, Aeron, gRPC, but this gets us up and running, started. So we'll point, oops, I just need for this one just to point to localhost, and 9091 is what the port was that I said I was going to use. So I'm going to inject this using Lombok's add all constructor, and we'll inject our RSocket requester, and let's get busy here. So I'm going to now create a post construct method, again, just to very simply demonstrate this. We'll call this channel method, and we'll use that requester to access the route. We defined a route called channel here. We'll send some data. In order to send some data, we need some data, and I'm going to just create a few observations here, an obs list, an observation list, and that will be a list of weather observations. So we'll have skies clear, visibility 10 statute miles, and let's see, we also need another one for broken 0.08, so 800 feet, and visibility 1/2 statute mile, and then scattered 77, so 7,700 feet, visibility 9 statute miles, and that'll be good. And then we also want, because randomness is fun, so we'll take a new random, and let's use that. So we're going to send some data. I'm going to just create a pulse, right, using a flux.interval, and we'll do this at a duration of 1 per second. And then I'm going to map that, so just the long value pulsing out of that, to a new weather observation. And we'll use, again, instant.now, because timestamp is good. I think that's good to always know where you are, when. And then we'll take our obs list and we'll get a value. And we will take our random and next int, and we'll use the obs list size just to limit that, to bound that. And then we'll retrieve the flux that comes back. So the flux, this is a flux of aircraft. And I'm just going to print this out. And of course, we need an airplane in here. Airplane. There we go. There we go. Okay, so let's go ahead and start that. Oh, whoops. I'm trying to cut corners on time, and what I wound up doing is cutting corners on code. So that's not a great thing to do. So let's just cut this. We're retrieving a flux of aircraft, and then we'll subscribe to that, because publishers you must subscribe to, right? The reason you subscribe to publishers is because you can't have a hot publisher that's always going and feeding data. But in most cases, oh yes, of course, in most cases, most publishers are cold publishers, because cold publishers are not active when nobody's listening. When no one subscribes, no work is being done. It's very resource efficient. So we're going to start this. And we see that our weather is, we're sending weather values from our thing1. We're getting back lists of aircraft, or technically fluxes or publishers of aircraft from thing2. Now, how are we doing on time, Teresa? We still have 5 or 6 minutes, right? This is good. Okay. So now I'm going to double back and show you some of these other interaction models, because I think I cut right to the chase in case we were really just crushed for time. But now we can just do some different things. So I'm going to, well, let's go over and do the other message mappings first. So I'm going to set up a message mapping in this case for request response. So I'm going to send back a mono of aircraft, and we'll call this request response, and we'll actually get a mono of instant, because again, I like timestamps. They tell you when you are. Timestamp mono. And we're going to receive, actually message mapping, rec response, and we're going to receive this timestamp mono and do on next. So we'll take our timestamp and we'll just kick that out. I like to, again, and I don't recommend you litter your logs with the emojis, but I do kind of like them for demos because it makes it really easy to see what's going on. So we take this and we want to return a single value. So that's the then, and we'll just do a client.get, retrieve those values, convert the body to a flux because we're going to get back as many aircraft as happen to be flying in that area at the time, and we'll just grab the first one. So we'll do that. We'll restart this, and then we'll go back over here, and we'll do our request response. Typing is suffering here. So we'll do our requester.route, and again, rec resp. And we'll send data, in this case, instant.now, and then we will retrieve we'll retrieve a mono. We're expecting one value back, only one. Class, and we'll subscribe to that again. Yeah, we'll use that. That's good. Oh dear. So let's see. I did it again. I try to get going too quickly. So there we go. That should work a little better. So we should get a value, a timestamp. We get back an aircraft. So let's go ahead and do another. So we'll push our luck. Again, I'm not a big fan of copy pasting, but desperate times call for desperate measures. So I'm going to take this. We're going to change this to a request stream because instead of getting back a single value, we actually want to get back a bunch of values, potentially as many as we have. So aircraft in the area. So we'll return then many. We'll remove this next because we don't need to just get one. We'll get them all. And we'll change the method name. So that will help. And that seems happy. Let's go ahead and start that. And then let's jump over here and do the same thing here. And here we go, request stream and request stream. And instead of retrieving a mono, we'll retrieve flux. And there we go. So in this case, actually, just to keep things straight in our heads, I'm going to, oh, of course. Well, that's fine. It sometimes doesn't cooperate, my keyboard, but we'll fix that. Again, new equipment, so always fun. So we're sending a value, we're getting back several values. That's our request stream. Now, in the last 2 minutes, I could show you the fire and forget. In fact, I'll go ahead and, what I think is more instructive than the fire and forget is when we take things and just blow them out, because I think it shows the absolute power of this. So remember I said this is a multiplex channel, right? So I'm going to just go ahead here, and I'm going to create another component, and we'll call this our thing one component two, right? And let's see, we want to do it at Alex instructor because I want to once again inject our reactive or RSocket requester, excuse me. And then, oh, actually I want to do the enable scheduling, because what I want to do now is do a scheduled at a fixed rate of 1 per second. And I'm going to just drop that there. So we're going to kick this off and query this just once every second. Well, actually, this is not a great example because we'll just do this. Because this is going to continue running anyway. So I will change this, or just move this down. But anyway, the same thing is going to happen, right? So this is going to be kicked off and running here, and this is going to be kicked off and running here, and everything's going to happen at once. That's kind of fun. And then after that, there's one more quick thing I want to show, and then we'll just go back to the slides. You can see the repo, and we'll answer questions. So yeah, so now we've got several different things. As you can see, we're getting we're interacting in multiple different ways between our different applications. So this is running, everything's running and talking back and forth across that same multiplex connection. So now I showed you this, and I showed you this based on TCP. So how difficult, how onerous is it to switch underlying transports? Well, it's pretty easy actually. So if we go to RSocket, I can type RSocket server transport, we can change this to WebSocket, and we'll restart this. And then we come over here to thing one, and we just say, we don't really want to use TCP. We want to use WebSocket. So we'll just change this to WebSocket and colon 9091. And then I just need to wrap that, and off we go. It really is that simple. It's just crazy good. So how effective this makes you. Now, I do want to say that this opens up a lot of possibilities. Obviously, there's a lot of communication that can happen between these two applications. There's resilience, you have resumability. So if you switch connections, that's always a possibility as well. You also have the ability to support multiple languages, multiple different underlying transports. And yeah, it's just so crazy flexible, and you're able to handle these interactions at the message level. So it brings up your level of abstraction and makes you indeed a more powerful developer in terms of being able to provide useful tools for your end users. So with that, we go back here. And there you go. So if you're interested in checking out the repo with this code and more, like the fire and forget interaction model, please do check out the repo at RSocket under my GitHub account at mkheck. If you want to know more about the Spring Boot book, just check it out on Twitter, and you can follow the link from there to everywhere else. And of course, if you follow me on Twitter, I talk about really cool stuff, cool tech, as well as flying and just fun stuff too. So with that, Teresa, I think it's back to you, and then we'll see what we have going on in the discussion.
All right, I put some of the questions in the chat there, or I can read it off to you. So let's start with question number one. Hola, amigo. What are the advantages of using RSocket instead of classic socket implementation?
Well, RSocket gives you, again, that message level of abstraction. It allows you to not worry so much about where, oh, I got a little static through there, where you're not, it handles so many things for you. So it abstracts the underlying protocol. It allows you to kind of elevate your thought to the message level again versus the packet level or the frame level. And of course, well, again, socket actually, it's not an advantage over that, but it's multi-language, multi-platform as well. So it allows you to think in terms of your application level constructs, I guess, more than anything, and message level. So when you're talking about interactions between the two, you're still keeping in that application and message mindset, which is very, very useful. You don't have to devolve in, and frankly, it's in that regard, it allows you to keep, I guess, a higher level of productivity, for lack of a better way to put it. Probably not the best short answer I can give, but that's what I'll end with.
Okay. And we have question number two. Do you have any recommended documentation for RSocket and reactive streams?
Oh, yes. Actually,
2 minutes left.
Okay, we'll make this fast. RSocket.io is the place to go for the first response, and projectreactor.io I think will give you Project Reactor, and of course I think it's reactivestreams.org or com or io. I think it's reactivestreams.org for some reason. But if you typically, if you go to rsocket.io, I think it links to Reactor, and Reactor links to Reactive Streams, reactive-streams.org, I think, now that I think about it. But yeah, just check into that. It's based on again, higher levels of abstraction down to lower, and frankly, it makes a lot of sense. It's a little different to get your head around at first, but once you start thinking in terms of those constructs, it makes a lot of sense. Yeah, so if you've ever worked with the Java 8 Stream API on up, you're probably not too far off the mark from getting started and getting productive pretty quickly.
Okay, and your last question, and you have less than 1 minute, is would RSocket become the reference for components to component communication at least within Spring? With RSocket, would that be the need for using a reactive web client except exporting existing HTTP endpoints?
Sorry, one more time on that. You kind of broke up in the middle.
Would Oops.
Oh,
Your session's actually over.
oh,
The question's in there. I have to end it, but feel free to answer it on the chat.
okay. I will answer what I can on the chat. If you think of something later, or if I miss something, please do ping me on Twitter. Thank you so much for coming, and see you in the chat.